Welcome to our YouTube channel. In this series of videos, we are going to learn how to model substation gantry structure using robot structural analysis. This is a stage 1 out of 3. In this, we are going to see about the principal drawing, which is the drawing we are going to use for modeling substation gantry structure. Second is gantry structure philosophy, which is a reference of our own YouTube video. This will explain you the philosophy about the gantry structure, where we can able to find out the components of gantry structure, loads and load combinations, standards to be used, tools and other softwares. Next, we are going to open the robot structural window, and in there we are going to do job preference, the fixing of unit of measurement, and the standards to be followed for material, loadings and design. Next is a tower. In this tower model, we are going to create the nodes and main members such as main leg, a dummy member at the top of the peak, and girder fixing tie members. So these are the main members which we are going to assign in this stage 1. Next is the tower segments. Based upon the splice and bracing pattern, we are going to divide the entire tower model into various segments. And finally, the support condition we are going to fix for the tower base. So these are the main content we are going to discuss in this stage 1 of 3. So this is a principal drawing which we are going to do modeling in robot structural analysis. So you can see a tower model and girder. Along with this girder, the tower total height is 21 meter. From the base to conductor and insulator fixing height is 16 meter. Above that it is 5 meter. So totally it is 21 meter. The girder depth is 1.2 meter. In the section 1.1 you can see it. And the bay distance is 16 meter. Bay distance is nothing but it is a center to center distance of any towers, two towers of any bay. Earth wire fixing point is at top of the tower, and conductor fixing point is at 3 faces of girder. You can see the point here. The tower is divided into various segment based upon the main leg and its cross bracing. For main leg, it is divided as a splicing of 3 numbers from the base to the girder fixing height. Similarly, the girder also divided into 3 splicing. 2 similar splicing nearer to the tower, which is 4.8 meter, and the mid splicing is 5.2 meter. So similar like the tower having 3 splicing of 5.6 meter, 5.9 and 5.7 meter respectively. Generally this splicing is very important because that steel fabricator or steel supplier may not have that total length of say for example 16 meter. In general, in market, availability of the steel profile is limit from minimum of 6 meter to maximum of 12 meter. Some supplier used to have only 6 meter of length of individual member. Some supplier may be having more than the 6 meter, maybe up to 12 meter. So it depend upon the steel supplier. We need to check the availability of maximum length. So based upon that availability of maximum length, we need to make this splicing in main leg. So we are made all the splicing which are limited to 6 meter. So next one is we need to segment the bracing member. So in a tower you can see there are 2 or 3 numbers of colors are used for cross bracings. One is in green color from the base of the tower, another one is blue in the mid, next one is green again. In the top peak it is a red, So likewise, we need to group it the members which are having a similar physical parameters and loading parameters. So we need to consider likewise. So this the grouping is very important to have it a minimize output sequence where we can able to identify which are the group or falls under the specific load transfer system. So likewise we need to identify the grouping. So similar like for girder also there are two groups of cross bracings. One is in magenta color, another one is blue color. So the first group magenta is nearby to the tower, another one is mid span. Then the panel are divided into various nodal points, that is joint connection. This cross bracing are divided as a 10 in 16-meter height, that is from base to the girder fixing height. So equally I had divided here, but in practical we need to check the requirement that may be deviated from this. So for this demonstration purpose, this 16 meter is divided into 10 equal parts, so that we are having a 1.6 meter as a panel height or segment height. So the base dimension of the tower you can see as a 2 meter in direction parallel to the girder span, and 3 meter in section 1 you can see in direction parallel to the span of the conductor or insulator. So this is a plan view. In that plan view, you can see the total distance of tower center to center distance is 16 meter. That is, bay distance is 16 meter. Face to face is 4 meter for conductors, and face to earth, that is center line of the tower, is 4 meter. So total it is 60 meter, and the base dimension of tower is 3 meter in conductor span direction and 2 meter in girder span direction. So this is the principal drawing which we are going to develop in robot structural analysis. This is a screenshot of one of our YouTube video. This will explain you the design philosophy of substation gantry structures. In this video, you can find the preliminary input, components, structural configuration, design procedures, design loads, design optimization techniques, and applicable tools and softwares which are required for substation gantry structures. Watch this video before going for modeling so that you can understand what is substation gantry structures. The link to open this YouTube video is provided in the description. You can find from there. So now you can see the opening page of robot structural analysis. In the right hand side of it, there are two pictures. One is a longitudinal view, another one is a transverse view of gantry tower, which we are going to model it in robot structural analysis. First we need to click new. In that there are some list of icons which are showing like building design, load takedown building design, frame 3D design, which is the exact icon which we need to select, and this shell design which is applicable for this underground tank slab without cutout or any FEM type of concrete materials. Truss 3D design is especially for roof and wall truss structures. RC designs elements. So there are various parameters which we need to select before going for any design task. So now for gantry structure we need to select frame 3D design, which is a third icon in the top. So this is a window. In that we need to define the job preference. We can consider the job standard is as per European. So here in the dimension we need to check whether all the dimension are in SI units. So for this job preference we need to go to tools, click job preference. So dimension all in SI unit, so no issues. And even the force movement also in by default it is in SI unit. If you want to change to any other unit, you can change it here by clicking this drop down list. And for others like rotations, angle, displacement, so all are in by default it is in SI unit for us. So if it is in FPS unit or a metric unit, you need to select it from here and change it. Similarly, like for length unit scales for 1 meter and force, so all the parameters are given here. If you want to increase the scales also, you can increase here. And materials, we can select the hero code out of various list here. So grade of steel, we can select it as 275S. So for concrete, we no need to worry about concrete, aluminum and timber, because we are going to design only the steel structures. Next one is go to database, and here it is stating only the UK sections, but we need to change that. For that, we need to select here in the steel and the timber sections. So we have to check whether hero code is available here or not. In some cases, by default material, European code may not be available, or if suppose I am going to design in American standard won't be there. So we need to click here, adding new database, and select from this list hero. You can click it, save current parameters as default, we need to click it. And vehicle load is not applicable for us, and standard loads, it is by default it is EC1, that is European code, let it be. Bolts, so reinforcement is not okay. Next is the design codes. So for design code, we need to give this parameters. For steel, by default it is European standard. If it is not there, we need to click this 3 dot and we need to select out from here. Also, you can click more to check other global standards like American, Russian, Indian, or any other standards which are listed here. If you want to select, you can select it from here. So far we need only steel and steel connection. We no need to worry about timber structure, RC structures and geotechnicals. So you can save it. And that's all we need to check. Now you can click OK. Then we need to create the nodes. For that, you need to click here. In the right hand side, there is a table like image. So it is also described that it is table. So that we need to click it and select the nodes. Click OK. So we have to have an Excel format or in Word format so that the joined nodes of base of the gantry, whereas here we can see it is a 3 meter in longitudinal side and a 2 meter in transverse side, and same in the girder connection level it is 1.2 meter in width and depth, and the top we are going to give 200 mm between the 4 angles which is going to meet at the pitch or top of the tower. So likewise we need to create some 12 number of nodes based upon its geometry and its dimension. So there is an Excel sheet we need to calculate, and if you are having those, you can just copy and paste in this node list. So here it means 0 0 means the first node. From that 2 meter in X direction, that is in transverse side, the tower base is having 2 meter, and in other side, that is in longitudinal side, it is 3 meter. So likewise, the based upon the dimension, the geometry of the node is created or calculated. And again some, so there are 16 nodes is a primary one. So we can make it this window tile horizontal so that we can able to view the model also. Here you can see some red color dot in the model view. So if we want to see it more clearly, you need to click here nodes list. there is some problem from ninth node. Yes, now you can see the tower view with tower nodal views. So these are the primary nodes of that tower. So from here we are going to draw a main leg of the towers. So for that we need to click the members icon in the right hand side. So by default there are some list of sections of angle. CAE is a angular section in equal size. So if you want to select more from the list, you need to click this three dot, select here steel, and the grade of steel is already we had defined as a 275. Here in the list you can see UK sections are showing here, but we need to select Europe as this demonstration is for European standard. And CAE is nothing but it is a equal angles. Here you can see the family description, and I am going to select here 150 by 15 as a main leg section in first level. Next level is 12 by 12. So this is already available in the list. So it is stating that. And the third splicing I am selecting as 100 by 10. Again it is telling it is available. And the fourth one, that is at the peak, you can see in the picture. It can be 80 by 8. Also this is also available. So for other bracings, tentatively I can consider 70 by 7. And finally for small cross bracings at tower fixing bracing, we can consider as 50 by 5. Again it is also available. So now from the drop down list you can find 150 by 15. So this is going to be our first splice. You can see here, because in any of the tower section which is having more than 6 meter or 12 meter, we need to check with the steel fabricator whether they are having the available length of angle sections. Generally that angle section used to have 6 meter minimum or 12 meter as a maximum with the supplier, steel supplier. So we need to check out that if they don't have more than 6 meter, we have to make it our entire length of the main leg into splices, which is to be limited to 6 meter. Even some of the supplier used to have up to 12 meter. So in that case we can go for up to 12 meter. So for the critical position, we are considering here as a maximum length of the angle member which are available in market as 6 meter. So we are making the splice as which is less than 6 meter here. So now we can draw main leg member. So from 1 to 5 there is one leg to become, and 3 to 6, so likewise 4 to 8, and 2 to 7, 4 leg. So similar like we need to draw all the leg members. So now we have drawn all the main leg members. So we can also draw the tie members, which is very easy at this level. So these are the connection point of girder. It's a bottom connection level, and this is a top connection level. So that node number 9, 10, 11, 12 are the top of girder connection level. So, and we can draw the dummy member which is to be connected this 4 leg member. So right now we no need to worry about the sizes which we are selected here, or sections which we are selected here. So later we can do this exact size for this. So now the dummy member also drawn, and if you want to change the section also, you can change it. You can consider 50 by 5. So now we are drawing the cross bracing at girder fixing level, top and bottom. So whenever you are going to pick a point or the node, you must see there should be some circular view of picking the point, because the circular means it is stating that you are selecting the exact node location. So sometimes this triangle means there may be some issues. So you must always select the exact location, means we need to find whether the circle is shown here. So now we had drawn all the possible members. We can also draw here the cross bracing, but we can draw while doing from the base. Next, we can assign support condition. Generally, the gantry structure used to have simply supported at the base, simply supported, that is a hinged support at the base, because this is going to connect with the base plate and anchor bolt arrangement to the foundation. So for that, to fix the support condition, we need to click the right hand side. You can see the supports image, and here by default it is mentioning the pinned. If you are double clicking this, it will show the fixed directions, because it is fixed in U, X, U, Y, U, Z alone. That is, it will fixed only in the vertical direction. It won't resist rotations, like it won't carry a movement. So then we can directly select the node 1, 2, 3, 4, which is at the base of the tower. So thus we had created the support condition. Now we are going to create segment, because a segment we need to create mainly because of one thing, we are having a splice, another one we are going to tie the cross bracing members. So for that we have to select all the 4 main legs from the base, and we need to go to edit, divide. So as in the picture you can see there are 10 segments. So we are typing here number of segments as 10, and we need to untick this generate nodes without member or edge division. It means if you are creating this 10 segment, let me try. So you can see here, if I am going to select this entire member will act like single member. Generally it is not the right way to model it in gantry structure. So we have to segregate this into simple length, because this entire gantry structure will fail in a slender if we are going to design it as a single member for about 16 meter. So we have to segregate in such a way that it should not having a length more than the slenderness limit. So for that, what we are going to segregate is, we are going to make this segment into small pieces in the range of 1.6 meter as described in the picture. So for that we need to untick or deselect this generate nodes without members or edges. Now execute. You can see the entire 16 meter is divided into 10 segments having a height of 1.6 meter as shown in the picture. So similarly, we need to split or make a segment here also in the peak level. Select, divide, edit, divide, and here you can see there are 4 segments. Again deselect this generate nodes. Now you can see there are 4 segments are created. So now this leg members of towers are ready to draw cross bracings. Thank you. Look description for more related videos. Subscribe to this channel for more updates. Thank you.